In this video, we're going to talk briefly about the inverse secant and inverse cosecant functions. What we want to notice initially is that the inverse secant function is going to have an output value that is in between 0 and pi. That's going to be in the first or second quadrant. Now this is convenient because the inverse cosine is also going to have an output that's in the first or the second quadrant. So the inverse secant being the reciprocal of the inverse cosine, we're thankful that this has the same exact range restriction as the inverse cosine. The one exception to this is at the angle pi over 2. And that's due to the fact that the pi over 2 angle has an undefined secant because the cosine is 0. Cosine of pi over 2 is 0. Secant at pi over 2 is going to be undefined. So when we talk about the inverse secant trig function, we're asking ourselves, who is the angle whose secant is x here? And noticing that at pi over 2, we do not have the option of having pi over 2 as the output angle here due to the fact that we would be having to plug undefined in for the input value. So we're not going to have an output possibility of pi over 2 for the inverse secant function. So that's illustrated here, that our output values are going to be somewhere in between 0 and pi, but not pi over 2. Similarly, when we talk about the inverse cosecant function, we have a range restriction from negative pi over 2 to pi over 2. That is in the first or the fourth quadrant. So that range restriction is also going to match the inverse sine function. So let's recall here that the inverse sine function is going to have output values in the first or the fourth quadrant, and similarly, thankfully, the inverse cosecant is going to have output values that are in the first or the fourth. Again, we're going to have an exception here at theta is equal to 0 degrees or 0 radians, and that is due to the fact that the sine of 0 is 0, and therefore the cosecant of 0 degrees or 0 radians is going to be undefined. So when we ask the question, who is the angle who has a particular cosecant, remember the inverse trig functions have outputs that are angles, so when we ask the question, who is the angle who has the cosecant of, we would have to put in undefined here in order to get 0 as an angle output. And so we can't evaluate the inverse cosecant of something that is undefined, so we eliminate y equals 0 as an output. Y is equaling to an angle of 0 degrees or an angle of 0 radians. That's not a possible output value for the inverse cosecant function. So let's look at a couple of examples here. We want to evaluate the inverse secant of negative radical 2. So again, we want to make sure that we understand this is going to have an output value of theta, or an output value that is an angle, and we're going to recall before we get started here that our only possible output values are going to be in the first or the second quadrant. So we're asking ourselves, who is the angle who has a secant that is negative radical 2? Now, since the secant is going to be a negative value, that tells me that I'm going to be in the second quadrant, because in the second quadrant the cosine is negative and therefore the secant is negative. So who is the angle who has a secant that is negative radical 2? That's going to be somebody in the second quadrant. Another way to ask this exact same question is to rearrange our inverse secant relationship in terms of regular secant. Here is another way of expressing the relationship between theta and negative radical 2. Who is the angle whose secant is negative radical 2, like this? So you may prefer to look at it in this form if you have a hard time understanding the inverse secant relationship. So the angle that we're looking for is over here in the second quadrant, and if the secant is radical 2, that's going to occur because the cosine is 1 over radical 2. So due to the fact that secant theta is radical 2, we understand and can see that the cosine of that angle should have been negative 1 over radical 2. Hopefully you recognize this negative 1 over radical 2 ratio. Most of the time we view this ratio instead as negative radical 2 over 2. So who is this angle that we're talking about? Well, it's a pi over 4 reference angle, but if it occurs in the second quadrant, this angle is going to be 3 pi over 4. If you're asked for your angle in radians, then 3 pi over 4 would be your answer. However, you could also be asked to express this answer in degrees, in which case you would want to say 135 degrees. So to draw your attention to the fact that these two examples that we're looking at here are going to have outputs that are known angles. We'll have a little different process when our outputs angles are not known angles, like for example if the answer were to be 37 degrees, somebody that we are not familiar with what its sine, secant, cosine, cosecant values are. But for these two guys, let's consider again the inverse cosecant 2 radicals 3 over 3. Well, this guy is going to have an output that is going to match the potential output values for inverse sine. As we know, sine and cosecant are reciprocal functions, and thankfully they actually have the same potential outputs on our inverse trig functions. So the inverse cosecant is going to have an angle that is in the first or the fourth quadrant as a potential output. Again, we cannot have an output value of 0 because the cosecant is not defined at 0. So the question that we're asking here is, who is the angle who has a cosecant of 2 radicals 3 over 3? Well, since this cosecant is a positive value, we know that the angle that we're looking for is somewhere in the first quadrant. So let's look at this inverse relationship from a slightly different perspective. Saying inverse cosecant 2 radicals 3 over 3 is the same thing as saying who is the angle who has a cosecant, regular cosecant, that is 2 radicals 3 over 3. So we may or may not be super familiar with it in this particular form. A function that we're a little bit more familiar with is sine. And so we can express this in terms of sine if you wish. However, something that's important to notice is that if we're going to express this in terms of sine, we really need to be working with the regular cosecant function instead of, it's a little bit trickier looking at the inverse cosecant function. So from regular cosecant, we can say, well, if regular cosecant is 2 radicals 3 over 3, we could express this in terms of sine by reciprocating this ratio here. I refer to this as a ratio because it's describing the ratio between the sides of a reference triangle. So if I were to express this in terms of sine, I would want to be reciprocating this value, the 2 radicals 3 over 3 value. So then it's going to look like 3 over 2 radicals 3, and after we rationalize that denominator, it simplifies down to being something a little bit more familiar, radical 3 over 2. Now it's a little easier for me to see who this angle is. If the sine is radical 3 over 2, that's because the cosine is 1/2. So we're looking for the angle in the first quadrant who has a cosine of 1/2 and a sine of radical 3 over 2, and hopefully we recognize this value as being pi over 3. If we're asked for our angle in radians, we would say pi over 3. We might also call this 60 degrees if we're asked to express our angle in degrees. So now, if we are asked to find the inverse secant of an angle that is not a known angle, for example, like 14 degrees or something that's not part of the unit circle that we memorize, then we'll have to use our calculator in order to determine the inverse trig function. Using your calculator to find inverse secant, inverse cosecant, and even inverse cotangent is a little bit trickier than you might think. We want to recall here that the cosine of an angle is equal to the ratio between two sides of a reference triangle, and the secant of the same angle is equal to the reciprocal of that ratio. So what we are reciprocating is the ratio between the sides on the triangle. Again, we are not reciprocating the angle. So let's look at this example here for just a moment. We're asked to find the value of the angle in degrees. We have the secant inverse of 5, and of course the output of an inverse trig function is always going to be an angle. Due to the fact that it's inverse secant, we know that the potential for the output angles is in the first or the second quadrant, same as inverse cosine. And the secant of the angle that we're looking for is a positive 5, and since the secant is positive, we know that we're looking for an angle in the first quadrant. Now, the angle is someone whose secant is 5. Let's think about the other way of expressing this relationship. Let's think about expressing it in terms of regular secant, saying that this is the same relationship that is described with secant theta is equal to 5. Now, looking at it from here, it's a little easier to describe this relationship in terms of cosine. If we want to try to reciprocate this value, remember, we are reciprocating the sides of the reference triangle here. So if the secant is 5, that's because the cosine of this same angle is 1/5. So we can express this in terms of cosine by reciprocating the ratio between the adjacent and the hypotenuse side. So if we're going to have to use our calculator, which we are because we are not sure in who this angle is, it's not one of our known angles, then we're going to have to use the inverse cosine function of 1/5 to determine that value of theta out here. So when we're expressing theta in terms of inverse cosine instead of inverse secant, what we notice here is that we are reciprocating the ratio between the sides, which is in the argument of the inverse trig functions. So we reciprocate the argument of the inverse trig function to get it in terms of either cosine in this case or sine or tangent in different examples. So to come back over here, we see that the inverse secant of c over a is going to be some angle. The angle is preserved. The angle is not what we reciprocate to get into cosine. And to get into cosine, we look at the inverse cosine of the reciprocal of the ratio between the sides. So we're reciprocating the argument of the inverse trig functions, and both of those would generate the same value of theta. So why on earth do we have to do this? Well, we have to do this in order to get it into our calculator because our calculator only gives us inverse sine, inverse cosine, and inverse tangent as inverse trig functions. We do not have inverse secant, inverse cosecant, or inverse cotangent. So we would, if we're asked to find the inverse secant of a value, we would have to express that in terms of inverse cosine. We were also asked to make sure that we are expressing the angle in degrees. That was given in the direction, so I want to start off by putting my calculator in degrees. And then in order to determine the inverse secant of 5, I'm going to enter into my calculator the inverse cosine of 1/5. Again, reciprocating the ratio between the sides of the reference triangle. That gives me my angle measured in degrees. And that's what we would write down as the answer for this question. Let's look at one more example, but this time using the inverse cosecant function. We're looking at finding the exact value of the angle. We're going to have it measured in degrees, and we're looking at inverse cosecant of -3. In order to evaluate the inverse cosecant of -3, we'll need to consider the inverse sine function because inverse sine is what we have access to on our calculator. So the inverse cosecant of -3 is going to yield an angle that is the same angle we would get if we were to evaluate the inverse sine of -1/3. We're reciprocating the ratio between the sides on the reference triangle, which is occurring here in the argument of the inverse trig functions. The angle is not reciprocated. So again, with our calculator in degrees, in order to yield an angle in degrees, we'll choose the inverse sine function, and the value that we'll put on the inside of the inverse sine here is -1/3. And we get an answer that is an angle measured in degrees. So our answer is the angle negative 19.5 degrees. And let's remember that that inverse sine, as well as the inverse cosecant, have outputs that are angles in the first or the fourth quadrant. And as we can see, our angle here is measured in negative degrees, meaning that it's putting us down in the fourth quadrant.